Example 6. What is the side length of the smallest square that could be tiled with rectangles that measures 8 inches by 36 inches? Assume the rectangles cannot be cut. Sketch the square and the rectangles. So here's the beginning of our square, except that, of course, this 8 inches should be over here somewhere. Oh, actually, should be right on this to indicate the width of that. And this 36 is the length of this. So now, that being said, if I could just do this, let's do this. Actually, you know what? Yeah. So now that we've done that, I can say, okay, well, if I need to eventually create a square with pieces that measure 8 by 36, it's got to be a square, which means this dimension has to be equal to this dimension, whatever it happens to be. What I'm going to be looking for is the lowest common multiple between 8 and 36. Because, you can think about it this way, because as I increase the number of rectangles this way, in order to get it big enough, I'm also going to have to increase the number of rectangles this way in order for it to be big enough. But remember, the length and the width of this shape have to be equal because it's a square. So yeah, I can add in a whole bunch of pieces that are 8 wide, but eventually I'm going to hit a number in which, well, now I might have to add in, say, a second width of 36 or even a third, depending on that question. So I continually do that. There we go, until I'd find the square. But instead of patterning that out, I can simply say, well, I know that I need to figure out what the lowest common multiple between both 8 and 36 happens to be. So I list them out. 8 times 1 is 8, times 2 is 16, times 3 is 24, times 4 is 32, times 5 is 40, times 6 is 48. Oh, well, yeah, holy, that's a lot, isn't it? So let's look at 36. Maybe we have a double up already. 36 and 72. Well, no, we don't. And 108. Oops, that's an ugly 108. 108. Well, I've already gone too big or bigger than that 48, so now I have to continue those 8s. So 48, and the next one would be 56, and then 64, and then 72, and then 80. Oh, wait a minute. 72, 72. These two are common. It's the lowest number common between the two sets. So the the least common multiple, in this case, 72 inches. The second example, what is the side length of the largest square that could be used to tile a rectangle that measures 8 by 36? Assume that the square cannot be cut. This question, we need to find the greatest common factor. So in this question, I list out, okay, here's 8. Here's my number 8. What are the factors of 8? 1 and 8, 2 and 4, and well, that's it. There aren't any more. 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9. Oh, ran out of room. 4 and 9 and 6 and 6. So what was this? This is 9, and then it was 12, and then it was 18, and then it was 36. So there are my factors for 36. Notice that, though, because it's 6 times 6, I still only write in just 1 6. Okay? Just a little rule that you kind of have to remember. You don't write both factors because it doesn't have two factors of 6 because it's the same number. You only have one factor of 6. But anyways, that's an aside. What I'm looking for is the greatest number that's common, between the two. And that number happens to be 4. So the biggest width and length of a square that can be used to make that 4 inches by 4 inches. Section 3.1 assignment at the bottom of the page there. Feel free to get started or save it for class, whichever you so choose.